So I am John Dickerson. I'm the third of the co-organizers for today's workshop. Thank you all for sticking around for such a long, but I think valuable day. So we'll have three final talks in this session. So from 3 o'clock until I guess about 4:10 plus change. I'll be the first speaker, and then we'll have two additional speakers, one from Maryland and one from ITIF, and I'll introduce them when the time comes. So without further ado, I'm going to go ahead and start speaking. So I thought I would actually speak about a slightly different topic than what many folks today have been talking about. So I wanted to give a case study and maybe a call to action for folks who sit at the intersection of sort of AI and HCI, human-centered AI, and other participants here in this workshop today. So I'll make it through some of these slides, and then I'll just sort of close out with a quick Q&A and a discussion. So I'd love to hear some feedback. So for those who don't know, I'm, I guess, more on the sort of core AI ML side, perhaps, than many folks in this workshop. So for me, this would be a great opportunity to talk with folks more on the core HCI side. Great. So I'll talk today about one particular case study of the use of AI in a morally laden societal system, something called organ exchange. So I'll start with this motivational quote from somebody, Al Roth, who won a Nobel Prize in economics for his work in part on the design of the market that I'll talk about today, which is markets come in many forms, some of which don't conform to conventional notions of markets, and some in which money may play little or no role at all. And so I'll start with this quote because I want folks to think about markets in the broader context of moving beyond something like, the NASDAQ, right? Or tracking the ups and downs of the Dow Jones Industrial Average over time. I want to think today about matching markets. Okay, so these are markets where we're not going to allow prices to do all the work of matching supply and demand. Indeed, we might have no prices at all, such as in the market that I'll talk about today. So in these markets, we have agents who are going to be paired with one or more other agents, transactions, or contracts. Some examples of these markets include the labor market, school choice. For those of you, for example, in the DC area or New York or Boston, there are central assignment protocols by which you express some preferences over schools for your children, and then those children are assigned in a particular way. The National Residency Matching Program matches doctors at the end of their residency, their 4-year MD program to a residency, matching patients to donors, which I'll talk about today, matching advertisements to viewers. This is another good example where prices do exist but don't do all the work of matching supply and demand. And then more recently, well, I guess pre-coronavirus, matching riders to rideshare drivers in systems, run by Lyft, Uber, Via, and so on. So today I'll talk a bit about kidney transplantation. Right? So in the United States, if you have end-stage renal disease, there are a few ways to stay alive. One of these is dialysis, by which blood is taken basically from your body, cleaned, and put back into you. This is a very expensive and it's just a very costly in terms of money and also health, mental health, as well as physical health process. An additional way to stay alive would be to receive an organ from a willing donor. Okay? So there's a giant waiting list in the United States, hovers around 100,000 people, for people who need a kidney, in this case. These are folks with end-stage renal disease who need a kidney to stay alive. Many folks will die due to kidney-related illnesses during these every year. Some will receive a kidney from a deceased donor. So this is somebody who is who's died, unfortunately, but has marked before dying that they are a willing kidney donor in this case. And in the event of their death, a kidney can be quickly harvested from their cadaver and then dispatched locally to folks on a waiting list. Okay, and this waiting list is prioritized in various ways. Okay? So this should be maybe hinting at some of the discussion of why this is relevant to this particular workshop, but somebody decided on that prioritization. Right? Some will also receive kidneys from a living donor. Okay? So it's the case that most of us could give one of our 2 kidneys and live basically the same life. So it could be that somebody with end-stage renal disease finds a willing, logistically compatible, and medically compatible living donor, and that person then gives their kidney to that person who needs a kidney, and they both leave happily. Now, more recently, folks designed a market for matching these patients and donors, wherein folks in need of a kidney can enter into the market with a willing but incompatible donor, and then trade these donors such that all participants in that trade receive a kidney from somewhere and leave happily. And I've done a fair amount of work with a variety of kidney exchanges worldwide. So here's a quick example of what a kidney exchange looks like, the most basic example. In fact, here on the right side, we have two patients with end-stage renal disease, a husband and a brother. The husband has a paired willing kidney donor, his wife, who unfortunately is not, say, logistically or medically compatible with him. Perhaps she has the wrong blood type to donate to him. Ditto, these two brothers, well, they're a willing patient-donor pair, but for whatever reason, this brother can't give to his brother. Wrong tissue type, wrong blood type, whatever. Now, it could be the case, right, that this wife could give to the brother could give to the husband, if they could find each other. So in the mid-2000s, an organized market for these patient-donor pairs was created up in New England, and it's since spread worldwide. Basically, patient-donor pairs are allowed to enter into the market, and then there's a matching process that occurs. Patients are matched to donors, and everybody leaves happily if a particular set of desiderata are adhered to. Okay. So as a computer scientist, we can view this as a graph, right, where a patient-donor pair is a node, and a directed edge goes from one node to another if the donor at the first, say the wife, D1, can give to the patient at the second, say the brother, P2. And the goal is then to find cycles where patients give to donors, donors give to patients, if and only if that patient's paired but incompatible donor gives to somebody else in that same cycle. So you can imagine cycles including 2 patient-donor pairs. You can imagine cycles including 3 patient-donor pairs or 4 patient-donor pairs, and so on. Now, there's a length limit put in place because as these cycles get longer, the logistics of setting up these transplants increases. A second sort of structure we might think about, right, is these non-directed donor-initiated chains, where we have somebody without a paired patient who enters into the pool and says, hey, I would like to give my kidney to a patient whose paired donor gives to a patient whose paired donor gives to a patient, and so on and so on. Now, these can go on for a very long time. I have some pictures here. For example, the University of Alabama in Birmingham had a 100-length chain that happened over a couple of years. These have been quite impactful in practice. Okay, so kidney exchange is about maybe 10 to 15 years old in the US, but it already accounts for, I think it's around 15% of living donations. It's worldwide. It's slowly actually moving toward international exchange as well, which will create a variety of new fairness issues, right? Is it okay to prioritize same country matches over intra-country matches? And I have some experience working with a couple of exchanges. So one of them is the United Network for Organ Sharing, UNOS US Nationwide Exchange. This has a large fraction of the transplant centers in the US, and it's run almost autonomously. So the matching process, deciding who gets matched to whom, is run by an algorithm. So let's say that I want to view myself as a kidney exchange designer, but I'm wearing my engineering hat, right? I'm trained as an engineer. I have a computer science degree. I have a stack of computer science degrees, right? So what's my job? Well, I want to design scalable algorithms that are, say, going to run this exchange, right? I want to have some performance guarantees. I want to make sure they converge. I want to make sure they do a good job. They are within X% of optimal, whatever that means. I want to make sure they accurately reflect stakeholders' wants, and I want to make sure that they're implementable, that I can run them in practice. Right? The end stage goal here being that I want to design some sort of system that finds the best set of potential transplants, subject to feasibility constraints, subject to legal constraints, and so on. And indeed, this should go without saying, especially this far into the workshop on human-centered AI, but the bigger problem here is defining the model itself, right? What is best? What's the objective? What are the constraints, right? In the case of, say, this particular case study, I might care about maximizing matches right now, or maybe maximizing matches over time. How should I deal with fairness? Should I prioritize particular, say, pediatric patients? Should I handle, say, biases that are part of the medical literature that might over or underestimate risk of particular transplants for particular subgroups of people? What sorts of other modeling choices should I include? For example, the incentives of different countries in an organized international exchange in the EU. Can I encode some sort of ethical consideration into this? What sort of legality issues might arise, right? So we've made this decision, for example, that money can't enter into this. That's a legal decision, that's an ethical decision. I'll make the claim that given all of this, right, optimization, machine learning, et cetera, might be able to handle this, but it's going to be inflexible. It's going to be hard to understand. It's going to be hard to audit, right? So what we might want in a system such as this, and this is where I would love to get feedback from folks in in this workshop is to keep humans in the loop at a high level and to let automation take care of the rest. So I'd like to just identify some of the issues that arise. And so, I mean, there's a lot of sort of sophisticated combinatorial optimization and machine learning that goes into actually maximizing an objective function in these systems. We can ignore that for the sake of this workshop. There's a lot of really interesting work that's gone into this, but I'd like to sort of identify other issues such as defining that objective. And to do that, right, we have to understand what sort of concerns might arise in our system that have that aren't ethically neutral. So one such concern might be fairness. There are many sorts of concerns in this space that arise in organ allocation. Some obvious ones, right? So race, socioeconomic status, age, these are ones you would expect to arise in organ allocation because they tend to arise in basically every healthcare application, right? For example, if you look at folks who are on the waiting list for a kidney, they are disproportionately African American compared to the percentage of African Americans in the United States. And this is due to a variety of reasons. One of these might be a correlate with lower socioeconomic status, which is going to correlate perhaps with different nutritional inputs into the system. And we know that obesity, for example, might cause diabetes, and diabetes might cause kidney failure. So there's a very complicated mesh here. And I mean, some of this was touched on by our previous speaker actually in the last session. And then there are some more nuanced concerns, right? So geographic location is one that pops up a lot in organ allocation. Steve Jobs, for example, famously took advantage of the ability that he had to fly anywhere in the country on a whim to multi-register across the United States to receive an organ that he needed faster than, say, you or I could, unless we can afford a private jet. Access to information is another one, right? So in the case of, say, organ allocation or kidney exchange, it might be the case that I just don't know that these markets exist, right? And so I just talk to, say, my mother, and she's willing to give an organ to me, but it turns out I know that she has the wrong blood type for me. And so we just never tell our doctor this, and then our doctor never registers us in an organ allocation, or sorry, an organ exchange. And this is just worse for us because we didn't know it existed. Some health characteristics, this is an interesting one. So if I just happen to be born with O-type blood, it will be more difficult for me to receive a kidney from a random donor than it would be if I, all things considered, were born just randomly with AB-type blood. And a very interesting one in the context of organ allocation is if I am, say, a woman and I've entered into a kidney exchange with my partner and I've become pregnant in the past from that same partner. So this is a very common patient-donor pair type, right? A husband-wife pair. It's more likely that I will be incompatible with my partner because I've built up antibodies to him due to pregnancy. The body sort of views this as an invasion and builds up antibodies to that. So in some sense, I am disadvantaged just by having children with this partner of mine. Okay. There are tons of these sorts of examples in the context of organ allocation. And I just want to get people thinking about this so we can have, a vibrant discussion in the Q&A session in about, 5 or 6 minutes. So keep some of these fairness concerns in your mind. You should also keep in mind a bunch of other stuff. For example, insurance in the United States is a bit of a, to put it lightly, a bit of a disaster for most people. So this will come into play, right? Do I have insurance? Do I have the ability to take time off of work? Am I going to be able to afford to take time off of work, and so on? So the first step in a system such as this, right? Well, I want to, or maybe I don't want to, but there exists, right? These exist. So I want to design an algorithm, right? That's going to match people such that I get as close to best as possible. So to do that, I need to define what best might mean in this context. Some concerns can be included in the objectives that are run here. For example, I might be able to include a particular type of fairness, such as giving a small bump to pediatric patients, or giving a small bump to people who are, all things considered, harder to match because of their blood type, right? I can do this reasonably easily by just putting a little additional weight in front of them and giving my algorithm a little bit of extra boost if I happen to match somebody like that. Some will be harder to include in optimization algorithms, right? If I, hard constraint, always want to match the most number of a particular class of patient. Let's say that I always want to match the most number of Johns that are in my pool, and then beyond that, I want to, do other things. That might be harder to include, but we can let optimizers deal with that. We can stack objectives on top of each other, right? So this might actually allow us to encode appetites for risks, such as in the United Kingdom. their exchange, which is entirely UK-wide, so 20 transplant centers. Every transplant center is included in this that does kidney transplants. They use a stack of 5 objectives where they maximize the first, and then subject to that, they maximize the second, and so on and so on and so on. These were also decided on by committee, by humans, and it's a form of prioritization. Now, a big issue, right, is there are many possible objective functions to use. If you're going to deploy a system like this, then you do need an objective function. One example, here's the objective function that the United Network for Organ Sharing US-wide Kidney Exchange uses. Okay, so it's a transparent exchange. You can look this up online. There's a PDF, a white paper published where you can just say, hey, how is this happening? Well, it turns out you start with some base score of 100 points. Okay, so there's a potential transplant between a donor and a patient. We give a base score of 100 points. And then you add or subtract points based on features of the donor and the patient. Okay, so if, for example, this first line in the table is saying if some healthcare characteristics line up exactly, give an additional 200 points. If the person has been in the kidney exchange for the last, say, 14 days, give them an additional 14 times 0.07 points per day. Okay. So this is the actual objective that is used, or it was used when I looked this up about 3 months ago. And the question that arises, right, is, well, this is deployed. Why? It seems to work okay, but why? So where did these features come from, right? Why did I decide that if there's a perfect match between this donor and this patient on this particular subset of the healthcare features that they have, then I will give them an additional 200 points? Where did that come from? Okay. Why 200? Why not 150? Why not 250, right? Where did that point value come from? And who decided that I should just sum weights in front of these features? Why should it be a linear combination of these particular features? Why is it this particular linear combination? Why can't it be, I don't know, something quadratic or cubic or whatever, right? In this case, this is a function, right? This is a function of a variety of stakeholders. This is a function of, obviously, medical experts. It's a function of medical research, legal research. It's a function of stakeholders such as patients and donors, and other stakeholders such as folks who run insurance, the government, and so on. And obviously, it's a function of the law, right? So the law you can view as a separate function of all these things as well, right? So it's very, very confusing all the way down. One big one, right? It's not clear how fairness considerations are going to play out over time. So this is a very dynamic system. So even if I can decide on a, say, definition of fairness and I can encode it into an objective function, it's unclear to me, right? It's unclear to me how that is going to play out over time over different, say, classes of patient or over the entire system. Right? Decisions made at time t are going to impact those at time t plus 1, 2, 3, and so on. Another big one is that input distributions are going to change. For example, the United States is getting more obese, and therefore incidence rates for end-stage renal disease may increase. And so if I train a system, say 5 years ago, it might not accurately reflect the inputs that I see right now. And again, this was touched on by our last speaker and some other speakers today. So again, it's important to quantify the impact and clearly communicate those wants from humans to the automated system and back. So what's our role as tech practitioners? Well, I'll take a view from an economist's seat. So I'll take a quick stab, and I'd love to get feedback on this because this is just sort of ongoing work I put together basically for this chat. So there's a nice model due to Shengwu Li, who I believe is up at Harvard now, he asked the question, how do we divide the labor between policymakers and, say, technicians and other classes of participant in the system such as this? So he'll split this into 2 groups, right? One is going to be technicians, such as, say, myself, and he'll claim that these are ethically untrained and ethically neutral. Love to hear feedback from this crowd on this. The other will be policymakers, right? These may not be technically trained folks. They're going to make ethically laden decisions, right? They're going to say, hey, I don't want money to be part of this system. That is an ethically laden decision. One goal that he asks for in this framework is informed neutrality amongst tech participants. So to him, this means that a tech participant is going to be informed neutral if they've become familiar, for whatever that means, with ethical theories and morally relevant aspects of, say, their work, but they're going to try to design options that remain ethically neutral. And this, to me, seems hard to implement. This is going to, because it's so hard to implement, necessitate close communication with policymakers. So these two classes of design participant, if I were to instantiate them in my case study called kidney exchange, well, technicians are going to be computer scientists, mathematicians, economists, right? These are usually not medical or ethical experts, but their work certainly has medical and ethical implications, right? If I design a better algorithm that somehow maximizes the total utility of a population, but I've hurt a particular subclass by doing that, right? That has ethical implications. The stakeholders in this case are going to be, say, medical professionals, policymakers, ethicists, the general public. Usually they're not going to be computer experts, but they're going to rely on computer-based tools, right? Doctors, for example, frequently rely on risk calculations, right? And these will have their own inherent biases as well. So I'll leave on this slide or the next slide, but a real-world challenge in this case is going to be how do we design a system that allows experts to collaborate to create something that is technically and medically sound and still somehow represents the stakeholders' beliefs. Yes, I'll end on this slide, and I'd love to hear feedback. I'd love to hear feedback because I live in my own sort of echo chamber, which is, machine learning AI economists, and it would be great to hear from the folks here. So here's a quick stab at a design feedback loop. We'll start with stakeholders who will define moral theories, right? It's not okay to use money in kidney exchange. They'll define, say, morally relevant features. Being younger than 18. This is something that's actually used in a lot of healthcare systems, prioritizing pediatric patients. That's going to be a morally relevant feature that I'll be allowed to build into an objective function. I'll pass these using some sort of language to technicians who will say, given these constraints, given these objectives, et cetera, I'm going to create a portfolio of design options, which will characterize the impact of these features on the underlying system. I'll pass back that characterization to stakeholders who maybe will select a design option and run with it, or use the feedback from those design options to refine their moral theories, return to point one, and continue this loop. I've focused on this primarily in my research, but I would love to hear thoughts on all of this. So I'll actually close out here. I have more slides we could go into, but I'll just close out here and maybe we can drop to Q&A.